Hello everyone, my name is Kevin Borden and this is Mark Casson, and today we will be talking about traffic signal inventory. We will be demonstrating the features of the Alabama Department of Transportation's Traffic Signal Inventory website, or TSI.
That's right. The TSI is used to display information associated with signalized intersections on state-maintained routes. In this video, we will demonstrate how to collect and record specific intersectional data.
Before the field visit, take a look at the aerial views of the intersection. Using this information, we can make a sketch of the intersection. Once on site, we will add other features of the intersection. Our initial sketch makes documenting the intersection easier.
Let's take a look at a field visit. We will demonstrate how intersectional data is gathered. To begin, we will need to gather general signalized intersection data, including details about the controllers, poles, mast arms, cabinet, detectors, UPS, utilities, and preemption devices. Let's start with the controller data. Once we open the cabinet, we need to obtain the following: manufacturer, model, serial number, imports, and the installation date. The same information is needed for the local controller and the monitor. Things like the manufacturer, model, serial number, imports, installation date, and notes are gathered from the site. Next, we will need to determine if the location works in coordination, and if so, determine the type of coordination system used. We will also need to know the available communications, such as TP, fiber RF, or other types. The mode of operation, such as actuated, semi-actuated, pre-timed, and the ring structure are also important inputs.
Another common operation is the adding or editing of poles. Let's gather our field data first. We will need to know the height of the pole, the number of bolts used, the diameter of the pole, the installation date, and the pole type, including aluminum, concrete, fiberglass, steel, and wood. We will also need the class of the pole and a description of the pole. TS is traffic signal pole, SP is service pole, or JU is joint use. Next, we need to count the number of luminaires attached to the pole and a description of the condition of the pole. Lastly, we can upload any documents or images from the location.
Another action that will require a field visit is adding or editing a mast arm. Data collected for a mast arm includes the length of the mast arm, the installation data, and any notes about the mast arm. Adding or editing cabinet data will require identifying the mounting type, pole or base, if it is mounted on a pole, the pole ID, the manufacturer, the cabinet model, any tag information, the cabinet type, and the width, depth, and height of the cabinet. We will also need the power source, power meter, and if the cabinet has a power disconnect within 50 feet of the intersection. We will also need the date of install. We can enter any field notes or documents for the site.
To add or edit a detector, we will need the phase or phases that the detector is used for, the number of detectors, the category of the detector, either vehicle or pedestrian, the location of the detector, the manufacturer, the model, and the type. If category is vehicle, then type is inductive loops, piezo sensors, magnetometers, radar, video, or hybrid. If category is pedestrian, then type is push button or other. Finally, we need to know the installation date and any note from the field.
If we have an uninterruptible power supply or UPS, we will need to know the operation type, such as natural gas, automotive gas, diesel, battery, or other. The fuel in gallons, numbers of batteries, the manufacturer, model, the mounting like base pad, pole, or cabinet, pole ID, battery, serial number, installation date, and determining if the UPS has a separate disconnect are documented. We can also add utility data. For each utility, critical data will include the utility type, the company, and contact number.
Adding or editing a preemption receiver will require us to know how the receiver is mounted, the serial number, the manufacturer, the model, and the install date. Adding or editing a preemption sensor data collection will include the manufacturer, the model, the location, if the sensor is associated with the cabinet, the railroad company that triggers the preemption, and the railroad contact number.
Now let's look at the characteristics of the intersection. For each approach, we would need to know approach heading, the route ID, the primary signal installation, such as mast stones, pole, or span wire, the auxiliary signal installation, if the signal is tethered, skew of the approach, and the grade. We will need to check for crosswalks, curb and gutter, sidewalk ramps, commercial driveways within 250 feet of the intersection, transverse bumper strips, pedestrian service phase, average distance from signal heads to stop line, and the speed limit. The sight distance is a dynamic number that is based off the speed limit and the average distance from the sign head to stop line. Street lighting is also included, and the ability to upload any images. We have the ability to add a mid-block crosswalk signals, such as a pedestrian hybrid beacon, rapid flashing beacon, traffic signal, or other system. Data we would need to know includes mounting, power source, the walk time, and the don't walk time.
Adding or editing a traffic signal requires information about the head configuration, manufacturer, model, the backplate, the color, the mounting height in feet and inches, the installation date, and the location, such as over the lane or between the lane. Adding a pedestrian sign requires the same information, but we'll also need to know if the signal is audible, the position of the signal head, and the activation type. Adding or editing travel lanes, such as left, through, shared, and right, will require field data collection. We will need things such as the length of the lane, the length of the taper, the width of the lane, if the lane is offset, the yellow clearance time, the red clearance time, and clearance distance.
Adding or editing signs requires that we first identify the correct MUTCD image, the mounting, whether overhead, pole, or other types, the location such as near side, far side, span wire or mast arm, the distance from the intersection, the installation date, and the manufacture date. To add medians, we will need to know the location of the median, the type such as concrete, grass, or other, the length, width, and if the median is continuous or not. School zone flashers, advanced warning flashers, and other ITS applications are all entered similarly.
Railroad crossings can also be added or edited. Data we will need to collect includes the distance the railroad crossing is from the intersection, the number of tracks on the crossing, if there are flashers, and the gate type. Now that we have all our information, this is a good time to complete the sketch of the intersection. That wraps up our look at the TSI basic functions. If you are interested in learning more about the ALDOT TSI system, contact the Traffic Operations section of the ALDOT Maintenance Bureau.